This is a production of Cornell University.
My background is in hydrology, so this talk is mostly hydrology with some kind of agronomy and agriculture thrown in, just so you kind of know what perspective I'm coming from. In terms of the project, I've been working on this with a grad student, Sherry Martin, who's here, and then also Dr. Teresa Selfa, who's at SUNY ESF. She's a rural sociologist. All three of us are actually have at least one Cornell degree, so I guess it's a good pedigree. So in terms of just some background on the project, so this is funded by USDA. So 2 years ago almost, they had a new program come out, the Water for Agriculture Challenge. Sort of the context of it was 2013, 2014, and clearly a lot of the motivation was because of the drought out west. So when I was sort of contemplating, is there anything to propose, can you really come up with anything as compelling as what's going on out west? So one question that kind of occurred to me, and I think have occurred to other people, is what is the potential if it's harder to sustain agriculture out west to shift agriculture back east, right? And that seems like a reasonable question to ask. With the idea of the intended impact of the Water for Agriculture Challenge is to ensure quantity and availability of water supplies. So if you want more water out west, why don't you take your agriculture somewhere where you actually have water? But then a few other questions arise with that. So one thing, so I was just looking at some papers. This is more of a climatology paper looking at water supply in the West. So this is just someone mapping out reservoir storage in the Colorado River Basin. So basically storage in the Lake Powell, Lake Mead. So that's the black line. So they're tracking that from 2005 to 20, or that's the green line. So from 2005 to 2014. But at the same time, what they also did is they also looked at groundwater. And the way they looked at groundwater is they used what's called GRACE, the GRACE program from NASA, which is the satellite program. And it looks at small changes in the gravimetric field of the Earth. And what they can do is they can detect, at a regional scale, changes in groundwater storage. So interesting thing with this graph is they basically saw 2010, 2011, people are concerned that Lake Mead might go dry. It basically recovers, but what they continue to see is they see groundwater levels go down and stay down. So this kind of suggests a few sort of interesting things related to my project and also Western water, which is, one, is that the drought has probably to some degree impacted Western water production. But to the other degree, it's Western production of agriculture has to some degree probably been mitigated by reliance on groundwater. So if we sort of look at 10, 20 years out when that groundwater isn't there, will there be a more obvious need for shifting things somewhere else? The third thing that it does in terms of some perspective for thinking about New York is it highlights the fact that even out west, where there's these irrigation districts and well-known basically is a definite need for managing water, there's been gaps in terms of understanding and management. And that big gap has been in groundwater. So people have been drawing down groundwater basically because there's no regulations there to manage it. That basically parallels New York. In the sense of, in New York, it's sort of been free reign in terms of non-potable water use. And I'll talk about this in a few minutes. Until only about 3 years ago, there were basically no restrictions in most of New York, not in the Susquehanna River Basin, the Delaware River Basin, but everywhere else. If you were a non-potable water user, so a golf course, a farmer, you basically could take as much water as you wanted, never had to report it, and never had to tell anyone. So to some degree, New York is sort of in the place where the West has been with groundwater, is we really don't know very much. Right? So this is sort of the two questions of this work is, can we shift agriculture back east? If we do that, and do we need water to do that? Have we basically been using more water for agriculture than we think in the east and in New York? And what do we actually know about how much water use there's been? Right? So those are sort of the overriding questions. OK, so basically 4 things we'll look at, sort of 4 different parts of the talk. First one is more anecdotal, but is there less water than we think in New York? And we'll do a little case study on Fall Creek. Second one is, how much do we actually know about agricultural water demand in New York? Third is, what sources of water could agriculture make use of? Right? We're very different than the West, where they have snowpack, they have large reservoirs. They've been planning for irrigation basically since the beginning of settling out west. And then the fourth one is, can we actually demonstrate a benefit of irrigation? OK, so a place to start is just thinking about sort of a case study of what do we know about water use in New York. So we're going to look at Fall Creek. One reason, it's nearby. Another reason, it's a good size, right? The watershed, at least above the gauge, is about 125 square miles. So big enough to actually have some water to do something with, but small enough to get a grasp on. So this is our map. So we're right here. Well, yeah, we literally are right here, right? The gauge, so one nice thing about this watershed is it's actually gauged. Most gauges in New York are either on New York City water supply watersheds or big rivers. So this is actually a relatively small watershed that's gauged. And then it has some interesting things going on in terms of water use. So there's the Cornell water filtration plant. Did most people know Cornell has their own water filtration plant? We do. Then there's several places where they pull water out for irrigation, all related to Cornell. So in Varna, they have some irrigation sometimes. And then there's the Homer Thompson vegetable farm out in Freeville. And then the other thing that's interesting too is there's a discharge of water from Dryden Freeville wastewater treatment plant. So that's actually inflow to the system. And for the most part, that water we could kind of consider it an out-of-basin transfer, in the sense that it's basically groundwater from homeowner wells or from deeper groundwater. It might be in the basin, but it's basically deep groundwater. It's not surface water. Okay, so then we can basically say, can we do sort of some water accounting for what we have available? So as I said, it's really only been in the last few years that anyone's really bothered to pay too much attention to what's available. So basically Cornell, as far as I know, has really only done made an attempt to sort of compile the records for the last 4 years. So going back to about 2011. Luckily though, we've had some really dry years in there. So 2011 and 2012 basically approach the historical lows in the summer. So the historical low is determined by going back, the USGS gauge goes back to 1925. So basically picking off the monthly minimum all the way back to 1925. So 2011 and 2012 come pretty close to those monthly minimums, right? So we can get a good sense of demand when you're actually at your minimum in terms of moisture availability. Okay, so let's look at some of the demands. So Cornell ag withdrawals, basically for irrigation. We can see sort of what we might expect, but often this data isn't available, is that when it's drier in 2011 and 2012, you use more water, and you use about 4 times more water. The thing to look at here, and we'll kind of put this all together in a minute, so everything is in MGD. Anyone know what MGD is? Some people, probably not a lot of people. So it's in million gallons per day. So that's in water supply, that's a pretty typical measure, is to use million gallons per day. Okay, so that's around 0.1 million gallons per day in terms of maximum irrigation demand. This is monthly average. This is the Cornell filtration plant. So they use quite a bit more. They use between 1.5 and 2 million gallons per day of water, and that's pretty consistent. As we've been doing this, we've been learning some interesting things about who uses water and how they use it. So the golf course actually uses filtered water from the water filtration plant, whereas most other places, well, irrigation on campus just uses unfiltered water. But we were sort of surprised to find that. OK, so putting these numbers together, so the one thing to realize is the withdrawals and the gains to the system are all upstream of the gauge. So the gauge is basically not telling you what's available before you take anything out. It's basically telling you what's available after you take things out. So it sort of is it's a relatively good indication of the lowest available flow. So if we basically look at filtration plant subtracting off, Cornell irrigation subtracting water, and then Dryden Freeville adding some water, and comparing that to 1964. This is the 1964 minimum, assuming the gains and losses are the same as they are now, which we're not quite sure if they are. This would be September 1964, including these current gains and losses. So we'd basically, it seems like if we look at historical minimums, drought of record, we would always have some amount of flow in Fall Creek. But 2.7 million gallons per day isn't much flow. Does anyone know probably what it's flowing at right now, Fall Creek? Want to put a number out there? I like to do this with my classes. I like to ask people, make some guesses. It's probably about, I didn't look at the gauge, it's probably around somewhere around 100 MGD right now. And in the summer, when you go out there and you think it's pretty dry, it's probably around 20 MGD. So if you say 2 MGD, we still have water, that's not a lot of water. That's basically a trickle of water. So main point is, right, if we look at this, we do still have some water, but not a lot. Right? So we can basically say within the historical record, drawing some water out of the system, we're basically getting to a point where if you take much more water out of the system, you have nothing left. Right? And people haven't really, as far as we've talked to Chris Bourdlemay, who runs the wastewater treatment plant, it's interesting. They have a number for what their maximum withdrawal can be, but it's actually based on their plant capacity. It's not based on hydrology. Right? So no one is really out there looking to say, are there minimums that we have to meet? The other thing, too, is that these are all based on monthly averages. Right? So we know within a month there's going to be variability, but then within a day there's variability. So if you go and look at the USGS gauge record, and this is instantaneous flow, it's every 15 minutes, you see this cycling like this. And we've actually been trying to figure this out for a while, what this is, because this only shows up in the last few years. And what we realized is Cornell changed the way they operate their plant, so now they turn it off at night for a few hours. But what this does is, if your daily demand is 2 MGD, but you turn it off for half the time, that means your demand when it's on is 4 MGD. Right? So, and if the irrigation works the same way, if they only turn it on certain times of the day, turn it off certain times of the day, your monthly mean, you might be meeting what you have available, but you could certainly be at a point during the day where you actually dry things out, right? Where your instantaneous demands exceed what you have. Okay? So it seems pretty reasonable, just based on this case study, that there definitely can be places, one of them being Fall Creek in the state, where if people aren't really looking at how we're withdrawing water, that we could potentially run out of water. One thing to note to this, and as we go on a little farther, is the way this operates is it's what we would call run-of-the-river system. Right? So out west or places like that, ideally what you have, it's not run-of-the-river. You have a reservoir or some storage to draw on. But here we're basically just taking whatever water's in the system is what we're taking out. As we talk about other potential sources in New York State for irrigation and water demand, what we want to look for is places where it's not run-of-the-river, where you actually have storage. If you think about New York, though, we don't necessarily have a lot of storage. We have the Great Lakes, we have the Finger Lakes, but they're not necessarily at an ideal point to make use of them. But we'll see a little later on where we might actually have a source that people don't always think about. OK, so kind of part 2 of this is to ask the question, besides just this case study, what else do we know about irrigation in New York State? Right? Are there any numbers out there? So there's basically 2 entities that sort of make an attempt to put some numbers together. There's USDA, so they have their agricultural census every 5 years, and they ask some questions about irrigation. They basically ask about irrigated acreage. And then there's USGS, US Geological Survey, that also every 5 years comes out with estimates of water use on a county basis. So these numbers, official government publications, they're out there. It's by county. It seems like it might be reasonable to trust it. So let's look at some of these. So I think it might be a little small, but you can probably kind of see it from the back, depending how young you are or old you are. So first 3 columns, USDA NAS, National Ag Statistical Service data. So that's irrigated acres. And then the last column is USGS demand in terms of MGD. Right? So comparing kind of apples and oranges. One is acres, one is actual demand. Just some interesting things to pick out. So Genesee County, and I'll show a map in a second. Well, I'll actually go do it right now. So if you don't know your New York State geography and you're wondering where these places are, so basically places with most irrigation, basically from NAS, Orleans, Genesee, and Wyoming counties. Those are sort of the 3 highest ones stacked up right there. And then Wayne County and Niagara County. Probably sources or what they're irrigating is a little different. Wayne and Niagara County, probably predominantly orchards. Well known, right? That's where most of the apple production is in the state. And then Orleans, Genesee, and Wyoming. Orleans and Genesee, probably more vegetable production. Wyoming, I actually don't quite know. I think it's mostly crops, but that's sort of part of the gap. I don't quite know what that is. OK, so then our other source is thinking about USGS demand. How consistent is this? The interesting thing about the USGS demand is it doesn't exactly correlate to the acreage. Right? The highest one for USGS demand does correspond to Genesee County, but you have other counties with relatively low acreage that still have relatively high USGS demand numbers. Right? If we go do just some back-of-the-envelope calculations, so I basically just took MGD, converted to cubic meters per year, something a little easier to think about, maybe, and then kind of look at a few possible irrigation rates. so basically centimeters per year, and look at how many acres irrigated would 1 MGD give you. So now we can kind of do a comparison between acres and MGD. So irrigation rate, it seems like 10 centimeters per year is probably the high end in New York State. It would be hard to believe you have a year that's much drier and you need more than 10 centimeters per year during growing season. So that would say 10 centimeter per year irrigation rate, you could irrigate almost 3,500 acres with 1 MGD, right? So that would, in Genesee County, if the numbers are right from USGS, 5 MGD at 10 centimeters per year would give you 17,000 acres. What NASA is reporting is 6,000 acres. Seems like a pretty big inconsistency, right? And that's even going to be true, especially when you look at some of these smaller counties with less acreage, like Erie County, 3.36 MGD, 390 acres. There's a pretty big inconsistency there. So clearly, something's missing that we don't know. Not surprising though, USGS does this for every county in the country, and if you look at the report, there's about 5 people on the report. So however they do this, it's some way where they really crank through it. Okay, but this basically raises more questions than it answers, right? It basically says, doesn't tell you anything about how often is irrigation occurring. If we trust the NAS data, which I think is pretty reliable, it basically just tells us it's irrigated. It tells us nothing about actual demand. It doesn't tell us how much water is being used. It doesn't tell us where the water is coming from. And then there's this inconsistency I pointed out. Okay, so as I've sort of alluded to, there's more data becoming available, and it basically is coming from the Great Lakes Compact, which was passed, or at least discussed and agreed to be passed back in 2008, and a basically agreement between states and provinces in Canada about how to manage their water. And New York State, as part of that, said they would actually start to try to track water usage, non-potable water usage. So in 2011, people who used over 100,000 gallons per day of non-potable water use had to basically start telling the state that they were using the water. It's basically voluntary in the sense that the state doesn't know if you don't report. So, but what it does is it starts to give us a data source. Okay, so what this is for the most part, people reporting to DEC, who's collecting that data. And this is, we geo-referenced at least the address associated with the user, which it might not literally be where it's taken from, but we're doing the best we can. And then this is overlaid over a crop map of different types of crops in New York State, right? So the yellow is corn, the darker green is soybean, the pink is alfalfa, and you can kind of see the darker red is usually, in some cases it's apples, in some cases it's dry beans and things like that. But it starts to give you a pretty good sense of sort of some distribution of things in New York State. Okay. The other thing we have added in here is, and I'll start to talk about this in a minute, is the Barge Canal Authority. Also provides water to people, and if you take water from the Barge Canal, you have to get a permit. So we also have the blue dots are people with a Barge Canal permit to draw water. Okay, so if you put this out there, this is sort of our best picture to date in terms of sort of site-specific users of irrigation water in New York State, right? And it basically matches up with what we knew from the NAS data in terms of people are centered in Orleans County, Genesee County, and there's actually a few more off the bottom. Let's see, let's go this way, which get cut off there down in Wyoming County. Okay. And for the most part, the dots lie in areas with agriculture, which is good. So it seems like it's consistent with what we're seeing. So at this point, no, we still don't really have any idea of demand, how much water they're using or where they're taking water from. One thing we do kind of know is, with the DEC data at least, it does give information about who the user is. So we can get some sense. Actually, there is a little bit of withdrawal data. I forgot. With DEC data, there is. So we have some sense of demand, and then we have some sense of what they're producing. And for the most part, as I guess we might expect, it's fruit and apples and vegetables. So things that would, horticultural products that would generally be more sensitive to water demand. Okay, so some examples up there. Okay, so one thing you might notice, and I sort of highlight here, is we have a large concentration along the Barge Canal. Right? Anybody from New York State? Have most people walked along the Barge Canal, just to get a sense? A few people. OK, a lot of people haven't. Right? So original Erie Canal, 1825, basically went from just outside of Albany over to Buffalo. At the time, upstate New York was mostly forest land, and it effectively opened up the western frontier at the time, right? Just about every city in New York State, in upstate New York, is basically on a river or on the Erie Canal, what was the Erie Canal. In about 1905 or so, the Erie Canal was 80 years old. They decided to update it, so they built the Barge Canal. In some places, it stayed along the same path, but in other places, like in the city of Rochester, it went around the outside of the city of Rochester. But you basically have this almost 200-year-old, kind of major engineering feat sitting out there. Interestingly enough, so I'll talk more about it in a minute, I think they have a budget of over $100 million a year. I think their revenue is about $100,000 per year. So if you ever wonder why your taxes are so high, or especially why it costs so much to drive on the thruway, you can partially thank the Erie Canal. So, OK, but this is where the Erie Canal goes on that western side of the state. It's basically totally flat, and it drains out of Lake Erie, and then here's Orleans County that it cuts across. And then it eventually hits the Genesee River over by Rochester. So basically, the reason all that irrigation is there is because they're taking advantage of the Barge Canal, of pulling water to the Barge Canal. And it's basically, it was, so two things, I guess. So the original Erie Canal was actually intentionally built up higher to avoid flooding. When they built the Barge Canal, they built it lower, so it actually intersects the Genesee River now, which is a good thing, because it basically means, what this is, it's basically a direct conduit from Lake Erie across the state, and it also can potentially pull water from the Genesee River. So if you start to talk about, is there actually infrastructure in New York State where we can draw upon stored water, the Barge Canal is it, because it's basically connected to the Genesee River and Lake Erie. And I don't think most people really look at it that way, but that's really what it is. So part of this project is basically thinking about, are there ways to sort of optimize the use of that infrastructure? Okay. Here's a nice view of things, 1905. Probably looks more quaint then than it does now. But I don't think it looks that bad now either. This is Medina. So this is engineering report from 1905, which was interesting. So basically, when they modified the Barge Canal from the Erie Canal, they intentionally recognized. So when you open the locks in the canal, you basically lose water. So you have to have a lot of water coming in. So what they realized was, so they intentionally made sure they had a large source of water, and here is the Erie Canal, or the Lake Erie. And they basically put a number on this, so they say that it has a capacity to provide at least 1,237 cubic feet per second of water in this portion of the canal. That's a lot of water. In terms of MGD, that's about equivalent to about 1,000 MGD. So there's a potential to supply a lot of water there. Another question you might ask is, okay, so if it's not the Barge Canal, are there other sources of water in the state? There are some aquifers. A lot of those correspond to glacial valley bottom aquifers. For the most part, they're not extensively tapped. There are some out there. Something else to consider. We might go there, but not necessarily. But just something else to put out there. OK, so despite the fact we know there's irrigation in the Northeast and in New York, I think the other question that's out there is it scientifically, is it defensible? Is it necessary? Right? We know people are doing it, so it seems like it must have some value. But is there other evidence out there of what the value actually is? Right? So, and I'll just say, surprisingly, there's really not that much information, right? I mean, there's a lot of farmers that kind of say, I think we need to do this, and they're doing it. But at the same time, if you start to look for actual scientific studies that show the need for it, there's really not many out there at all. So the one thing that complicates things, I think, as most kind of agronomy people know, and especially in the Northeast, is you have lots of different factors controlling yield. Right? So I kind of at the top here, I just picked corn just because it was a nice image. I could find it easily. Right? But at the top, I sort of have different factors that can affect yield. So clearly in the Northeast, early season wetness is a big one. How soon can we actually get in the field and plant things? Once things actually start growing, is it actually warm enough for the crop? So do we accumulate enough growing degree days? Once things are growing, do we have rain we don't want? So do we flood our field? Are things too wet? And then finally, once things are actually getting mature and there's actually quite a bit of water demand, do we still have enough water? Right? And this is really, the fourth one is the one we're really asking. That's the one we're trying to control with irrigation. So the difficulty in trying to understand is how much of our yield is dependent on moisture availability is also trying to identify these other controls on your yield, right? So you basically have a bunch of factors, a lot of them not related to moisture availability, or at least a moisture availability deficit that you need to kind of eliminate to see how important that other factor is. Okay, so this is just showing kind of peak demand for corn. It's about 60 to 80 days in. So by July, August, right? That's when we'd be most interested in having water. Okay, so some interesting studies from people in Canada, actually. So I guess a group, Cowan and all, they were looking at horticultural crops. So they were doing two things. They were looking at temperature, and they were looking at mean seasonal temperature, and then they were looking at just days over 30, so just sort of short, sporadic changes. So they saw for a few things, cabbage, cauliflower, some significance just in days over 30 degrees. And then they actually saw some significance with days with rain. Not with growing season precipitation, but basically short periods without enough rain. So a little bit of evidence there. Other sources of evidence out there that irrigation might actually matter and sort of potentially be useful in the Northeast. So crop insurance data, which is out there, as we can see. So this was for apples. Blue one for kind of, this is indemnities for crop insurance. Certainly for apples, freezing is a much bigger deal than excess moisture. Well, actually, excess moisture doesn't even show up here, right? So we do know they irrigate apples, but it appears, and that might be the reason it doesn't show up, is because of the it's already irrigated, so people don't need to, don't include it in terms of crop loss. Corn, irrigation does show up. So most years, at least lately, we've had too much water, but 2012 is a dry year. It did show up as people claiming crop insurance for lack of water. Okay, and then we've also been doing some of our own analysis using NAS data, so National Ag Statistical Service data, using county level data. And what we've just been doing is just starting with relatively simple things, so just trying to predict annual yield and using growing degree days, using June precipitation and July precipitation, basically for sufficient water, and then using May precipitation for being too wet early in the season. So this is for Livingston County. This is down near kind of Danville in the kind of the center of the state. And you can see here, not a great model, but the main thing I kind of look at is, do we get the quadrants right in terms of observed versus predicted? And the other thing to note is that here, importantly, if you just try to model just using GDD and early season wetness alone, it's not significant. So only when you put in precipitation, kind of summer, July, June precipitation, is it significant. So again, some more evidence suggesting that yes, precipitation or moisture during the growing season is important. Things get complicated though. So this is another county. This is Genesee County. And in this one, we actually find the best model is actually just includes GDD and just includes May early season moisture, not summertime precipitation. So we're not quite sure, right? This is where they're in the process of kind of deciphering. If you move around county to county, why do things change? One thing, there is a little bit of irrigation in the county, 2%, but probably not enough to make a difference in terms of changing these relationships here. Possibility is soils. They might have deeper soils. So even if you have less rain, you have more moisture availability over time. But we don't quite know. So we're basically trying to kind of decipher these relationships and kind of get a better sense of what's going on to make the case that irrigation is actually potentially useful. Right? And then this is only for corn, for vegetable crops and things like that. It might be a different story. Okay, so kind of the final part of this is when we consider this, and part of this project was sort of considering historically what's happened, but then also part of this is basically looking at potential for climate adaptation with the assumption that things likely and will change in the future. So at this point, we haven't done our own work, but looking at what other people have done. There was a paper by McDonald and Gervitz about 2 years back, and they, for the entire United States, looked at moisture deficit using climate models. And then they basically, on changes in moisture deficit, they used historical relationships to irrigation given moisture deficit and projected how things might change. So for New York State, they said there might be an increase of up to 25,000 hectares in irrigated acreage, or yeah, hectares in irrigated land. So they recognize something. Kind of a well-known study, Anderson et al. From about 5 years ago, looking at a climate assessment in the Northeast. They also use climate models, looking at changes. This is in soil moisture, seasonal summer soil moisture, and they saw a decline in summer soil moisture. Although it's a climate model, so you can't put that much, if any, trust in it. But it seems like they did see a decline of about 1 centimeter, so not a huge amount. So it seems reasonable to think that in the future there'll be some additional moisture deficit, and that might be equally important to not only looking historically, has there been a need for irrigation, but basically changing sort of the equation of can you justify it more in the future. Okay. So as you can kind of tell, project is basically ongoing. We've been doing this for about 6 months, and we basically are going to do it for another year. But I think we can make a few conclusions already and then think about where we're going to go. So first thing is basically given the reliance on run-of-the-river supplies in New York State for the most part, it does seem like there is potential for conflict between users. I do know, like say for Fall Creek, we belong to a CSA, which is Ithaca Organics. They recently started farming right next to the Homer Thompson vegetable farm, and they have a plan to irrigate. So there's lots of small users out there who might be using water that don't necessarily fall under the 100,000 gallon per day threshold to report, right? So for now, those people kind of remain invisible, but if there's enough of them, they might matter. Let's see, there remain inconsistencies in what we do know, right, in terms of NAS and USGS. There's basically no consistency, or there's little consistency between that data that's being put out there. So clearly gaps in reporting. Despite not really being intentional, the Barge Canal seems to be a really interesting piece of infrastructure. It's currently being used to some degree, evident by the number of people clustered around it. But I think there's interesting questions to ask of, is there a capacity to put more people around it? And one thing I don't really get into because I don't have the information yet is, right, there's an expense with irrigation. And to irrigate, you basically have to say, is the economical benefit from what you can get in increased revenue, does it equate what you have to put in terms of capital, right? The Barge Canal is potentially interesting because everything's nice and flat. It's already right there. It might be a pretty cheap source of irrigation in New York. So it might be a pretty economical way to irrigate nearby. Based on sort of some analysis of what data is out there, dry periods do cause measurable declines in yield, despite other factors that cause measurable declines. So it's definitely, we can see it. It's just a matter of better eking out, what is that as a total percentage of loss, really. And that's sort of the economic part. And then, as I said at the end, climate change will probably make things more economically feasible. It seems pretty likely things are going to become drier in the future. How much remains to be seen. So kind of remaining parts of our project are basically to do an intensive survey in the next few months of farmers to basically get more focused information in terms of what sources of water they're using, how much are they using, and what kind of irrigation equipment are they using, and also what are they irrigating. And then to also continue on with doing more crop yield modeling to get a better sense. But in the end, I think it should be sort of an interesting picture of sort of this, to a degree, sort of untouched consideration of non-potable water use in New York State. And going out in the future, it might be some potential for future investment in irrigation in New York if you can kind of make the case that there's a place to boost production without basically having too many competing users for the water. So I'll end there, and I'm happy to take questions.
This has been a production of Cornell University, on the web at cornell.edu.